Hello everyone, welcome to our channel Code with Sunny, and today we will be discussing the problems of Google Kickstart Round B 2022. Yes, today is the Google Kickstart Round B, and there are four problems in this contest, and we are going to discuss each of the problem one by one. In the contest, I was able to still the contest is running. The fourth problem is quite tricky. I am not being able to solve the complete part of this problem. I've taken only the partial points. Okay, so I will try it out in the remaining time. For now, let's discuss the very first problem, image labeler. Okay, so this problem is basically this problem basically requires the simple mathematical approach. You need to know the concepts of medians and all, and how to we are going to maximize our answer by having the optimal distribution of the elements. Okay, so I will tell you out all that in this video. For now, let's understand. So, crowdsource is organizing a campaign for image labeler task with participants across n regions. The number of participants from each of these regions are represented by array this. Okay, so let's note down all the important informations. So we would be having an array A that has the elements A1, A2, and it goes up to AN. Okay, and that is basically denoting the number of participants in a particular region. If A1, A1 will denote the number of participants in the region 1. In the image labeler task, there are m categories. Crowdsource assigns participants to these categories in such a way that all participants from a region are assigned to the same category, and each category has at least one region assigned to it. Okay, so there will be m regions. Okay, so let's denote the regions as b by the value b1, b2, and it goes up to bm. Now, according to the problem, we need to assign the participants present in each of the regions to any one category. We are assigning the participants in region A1 to B1, and we are assigning participants in region A2 to B2, and so on. Like, you can also assign the participants present in the region A2 to B1 also. Okay, and you cannot split the number of participants in A2 into more than one parts. Like, suppose A2 is 5, then you cannot split into 2 or 3 or any of the divisions, and then say, you are going to claim that yes, I am going to divide, make it value 2 move to the B1 and value 3 move to any of the other categories. This is not possible. We are going to pick up the all the participants in this particular region, and we are going to assign it to any one of the values present over here, b1, b2, b. Okay, there will be m categories, and each category must contain at least one region. So the categories b1 to bm must not remain empty, any one of the categories. The success metric of campaign is measured by the sum of the medians of the number of participants in each category. Okay, and let us remind you that the median, so there is a concept of median. If the total number of elements present in the set is odd, we have the sorted set. If the total number of elements present is odd, we need to check out the middle element, and that will be a median. Note that the set will be sorted, otherwise we need to take the average of the two middle elements if the set size is even. Okay, so yeah, so how we are going to partition, how we are going to assign these regions to these m categories, such that the value, maximum possible value, we are going to get for the success metric. Okay, and yes, the division, how do we calculate the success metric of the campaign? Okay, so the success metric of a campaign is measured by sum of the medians of the number of participants in each category. Okay, so suppose there exist three categories. Okay, so categories are B1, B2, and B3, and let's suppose there are five regions. Okay, and the regions are A1, A2, A3, A4, and A5, and we need to assign these regions to these three categories. Okay, so let's say that there exists an optimal division, not calling it as optimal right now, let's say there exists some division where B1 contains A4 and A5, and B2 contains A1, and B3 contains A2 and A3. Okay, so the success matrix is defined as sum of the medians of uh, all those values present in each categories. So we need to find out the medians of A4 and A5. So that will be A4 plus A5 upon 2 because size of the set is even, and median of this will be A1, and similarly this will be A2 plus A3 upon 2. Okay, note that the elements present in each category must be in the sorted form. Then we are going to calculate out the median. Okay, so the very first question is, how do we perform the division? Like, how do we assign the regions into the suitable categories? Okay, so let's try to understand this one also. So the one more thing I need to add is all categories must be non-empty. According to the problem statement, there is mentioned that the each category has at least one reason assigned to it. Okay, so how do we perform the optimal division? So let's say we have the M categories, it goes up to M, and we have the n reasons. We have a1, a2, and it goes up to an. Note that m must be less than or equal to n. So if m, like size of the like number of categories must be less than or equal to n, because then only the division occur and all the categories will remain non-empty. Otherwise, if m is strictly greater than n, then one at least one of the category will become empty. Okay, so this will not be possible. That's why m must be less than or equal to n. If you look out the constraints, m must be less than or equal to n. Okay, so how do we assign these regions into these categories such that each category will remain non-empty and the sum of the median success metrics will be maximum? Okay, so the very best case is, let's say first we have sorted this sorted array of A, which is the regions, participants in each of the regions in non-decreasing order, or let's say non-increasing order. Okay, so it is obvious that A1 must be greater than or equal to A2, must be greater than or equal to A3, and it goes on up to AN. Okay, and each of the category will remain non-empty. So what I will do is, like, I will assign first m minus 1 categories starting from b1 b2 and it goes up to m minus 1 with first m minus 1 greater values. So it should be like b1 will be assigned with a1, and b2 will be assigned with a2, b3 will be assigned to a3, and so on, and here will be bm minus 1 will be assigned with am minus 1. Okay, so note that we need to maximize the median, and median for the odd size is the middle element, and for the even sizes average of the two middle elements. Okay, now since we need to maximize the sum of the medians, we will always try to put out the maximum element, and the size of this set for the very first category will be always 1. Okay, if I will assign only one reason to this category, and that reason has the maximum number of participants, then the median will always come out to be a1, and for this set median will always come out to be a2, and for this one median will always come out to be a3. Note that a1, a2, and a3 are sorted in non-increasing order. So when you calculate the sum of the medians, you will get a1 plus a2 plus a3, and it goes on up to am minus 1. And what I will do is, like, there will still remain one empty set bm, then I will put out all the remaining elements. Like, the remaining elements will be starting from am. Note that am minus 1 will be assigned to bm minus 1. Okay, so all the remaining elements will be put out in this bm category. So I will just write down the median of remaining elements. Okay, and the remaining elements are the starting from am to an. Okay, note that I have filled am minus 1 up to the element am minus 1 to this bm minus 1. Okay, like all the elements, first m minus 1 elements are assigned, and each category will contain exactly one element. Why each category will contain exactly one element? Because if you calculate the median of the category which contains only one element, you will get the element as it is. When you get the element as it is, you will try to maximize the sum of the medians. You will always try to put out the maximum elements. A1, A2, A3 are the maximum elements present in this. Like A1 is the first maximum element, A2 is the second maximum element, and so on. When you try to put out exactly one element in these categories, b1, b2, bm minus 1, you will get the sum as sum of the medians a1, a2, a3 up to am minus 1, and this is maximum. And and also you have to try it out for the remaining element to get maximized. You will try to put out all the remaining elements into bm category, this category, and then you're going to find out the median of this bm category and sum up all the answers you are going to get. Okay, so the key idea to solve this problem is to sort the array A in non-increasing order and always try to put one element into exactly one category till exactly one category is left, that is bm category is left, and you have to assign all the categories up to bm minus 1, that is m minus 1 categories, to like all the categories will contain exactly one element, and that one element will be assigned starting from the maximum element, so that when we sum up all the medians, you will get the sum of first maximum element, second maximum element, and so on. And for the last category, you need to calculate out the median, and then you are going to add up to your answer. Okay, so let's look out how we are going to implement that. Yeah, I have that implementation. Let me copy it and let me just. Okay. I hope the screen is visible. Okay. Yeah. Okay, so what I've done is I've taken the array, and there is also a remaining elements array which we will deal it out later. So first I have sorted all the elements in non-decreasing order, then I have reversed the array, which is basically sorting all the elements in non-increasing order. So I have taken initialize as answer as 0, and for first m minus 1 categories I will put out the only maximum element starting from the first maximum element. You can see answer plus equal to array of 5. Okay, and for the last category, we will put out all the remaining elements and find out the median and add up to your answer. This will maximize the success matrix. Okay, according to the problem statement, we need to calculate the maximum success metric that we can have. So I have put out all the remaining elements, sorted it, and then find out this size of this remaining element. If it is odd, I will have to work for the middle element, that is the middle element will be the median. Otherwise, let's calculate the sum of these two middle elements, and we are going to divide it by 0, like divide it by 2, because we need to take the average, and finally we are going to print it out the answers. Like though you have to check out for the precedence also, like it should be 10 raised to the power minus 6, that is the relative error. So for the safe case I have taken it as 10. So this will give you all test cases passed. Okay, so if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video, and do not forget to subscribe.